Hello and welcome to Frap Talks, where we discuss anything related to modular synthesis with Frap Tools instruments. Today we will talk about this, and this. We will talk about Glissando, Portamento, Slide, Slew, and everything in between. And to do so, we will use three modules: USTA, FALISTRI, and BRENSO. All the patches that we heard before had something in common. Sometimes the melody seemed to slide between the notes instead of being sharp and articulated. This kind of motion between notes by raising and lowering the pitch is known in music as glissando or portamento. Some musical instruments like the trombone or fretless instruments or even the human voice can naturally perform this kind of continuous movement. In modular synthesis, however, the notes are generally achieved through discrete values, and in the specific case of Eurorack synthesizers, such values are the volt per octave standard. If one tries to perform a glissando on any volt per octave controller, the result would be similar to a piano or a fretted instrument such as a guitar. The notes will still be recognizable because the controller itself doesn't allow any other value between them. But modular synthesizers are modular, so we can always hope to find a module that does exactly what we need. In this system here we have three modules that can help us achieve a proper portamento: FALISTRI, USTA, and BRENSO. Let's start with FALISTRI. The section that interests us is the linear slew limiter, colored in blue. A linear slew limiter creates a continuous linear transition between two discrete voltages. It is often called integrator because it integrates those two discrete voltages with theoretically any other value in between. We use this circuit to smoothen any voltage transition, let it be from low to high or from high to low. The controls of a slew limiter define how long does it takes for such an integration to happen. And in fact, FALISTRI has separate controls for any of these two transitions, so that we can have a faster glissando going up and slower going down. It is called linear because it integrates those two discrete values with a linear progression of volts per millisecond. This means that if it takes a certain amount of time for the integrator to integrate two values, let's say 0 volt and 1 volt, which is an octave in musical terms, it would take it twice that time to integrate from 0 volt to 2 volts. For example, if we play two notes one after another, like C1 and C2, our glissando may last, say, half a second according to our slew limiter settings. If, however, with the same setting we play C1 and C3, our glissando would last 1 second. A consequence of this is that it takes less time to tie together shorter intervals than larger ones, and this can create very interesting melodic lines. This patch sounds a bit stiff. Let's take the volt per octave cable and route it through FALISTRI's slew limiter before it reaches the BRENSO oscillator. Then we'll define the integration time for the rising and falling segments. If we set the right knob fully counterclockwise and play with the right one, we will obtain a legato over the descending notes only. In the opposite case, only the ascending notes will have legato. But the volt per octave signal is not the only thing that we can integrate. If we patch our keyboard gate signal straight to our VCA CV input, the sound passes through only when we push the key. Generally, a more elegant way is to use the gate to fire an envelope and then patch the envelope, not the gate, to the VCA CV input. However, if we've run out of envelopes, we can route the gate through a slew limiter. It will smooth the abrupt transition of the gate signal and provide a similar effect. By default, FALISTRI's slew limiter input is semi-normal to the yellow envelope. We can see the LEDs flashing as it integrates the yellow envelope and makes it longer, and we can also hear how different the envelope sounds after the integration. Let's keep our integrated envelope to control the VCA and patch the yellow envelope to the BRENSO's wavefolder input. In this way, with just one envelope, we can send two different articulations to the timbre and the amplitude sections of our patch. First, let's use the slew limiter to create a gummy bass line. Then, let's add a kick drum. The slew limiter output is its integrated version. Let's patch it to the 3-2-1, invert it and add a positive offset, so that it would work in the opposite direction than the kick drum. Then, let's patch this to the VCA CV input. Now the kick envelope will duck the baseline and the slew limiter will define the attack and release time of the sidechain compression. Now let's move on to the BRENSO. Within its circuit lie two separate oscillators that can be fully independent, each with its own volt per octave input. Halfway through the two oscillators, however, there is a linear slew limiter that creates a portamento effect on the green oscillator using the same volt per octave signal that we patched to the yellow one, allowing some expressive effects. Its behavior is indeed quite similar to the linear slew limiter that we saw on FALISTRI, but it has two major differences. The first one is that BRENSO's slew limiter controls both the upward and downward integration with the same knob, without having two separate controls as we saw on FALISTRI. The second one is that such an integration can be voltage controlled. Let's see some practical examples of this feature. We can obtain a classic mono-synth legato effect with just the green oscillator when we patch our CV to the yellow volt per octave input and play with the integrator. If we exceed the integration, we'll turn off the circuit, and the green oscillators won't receive CV signals from the yellow one anymore. Things become more interesting when we listen to both oscillators. The yellow one will immediately change its note, and the green one will somehow chase it. As you can see, however, there is a CV input that goes straight to the integrator level. Patching a CV to this input will change the integration time accordingly. We can try to patch a random voltage and create random lags here and there. It can be fun, however, to control the slew limiter with the same volt per octave signal we use for our notes. This will cause the high notes to be sharper and the low notes to be more glued together. In this patch we are using the green oscillator to perform a through-zero frequency modulation over the yellow one. Integrating the voltage between the yellow and green oscillators creates a short or long transition zone between two notes, in which the carrier and modulator ratio continuously drifts apart before returning to its defined value. Let's set the green oscillator to flip sync. Now the yellow oscillator will force it to the rising part of its waveform at every cycle, creating some nice overtones. If we start playing with the integrator, we'll obtain some pleasant sync sweeps. We can blend the two oscillators and obtain a fatter tone. The last module that we'll talk about today is the USTA sequencer. We kept it for the end because even though its slew limiting concept is pretty much the same as we saw on FALISTRI and BRENSO, its implication and application are completely different. So USTA is a sequencer, meaning that its stages store and then play discrete volt per octave values, just like the one on the keyboard that we used before. This behavior is displayed on the user interface by the blue stage LEDs. However, by pushing the stage encoders, we can change the way USTA plays such discrete values. We can see that the stage LED changes its color from blue to green and from green to red. The red color is not relevant for us at the moment, since it sets the stage to play the previous stage's value. In other words, it prevents the DAC to update. What we need instead is the green stage color, called slide. When we set a stage to slide mode, instead of playing the value that we enter with the stage encoder, USTA will set it as a target and creates a linear integration from the previous stage's value towards it. The result is a continuous and linear integration that starts at the end of the previous stage and land exactly on the desired note at the end of the current one. And here lies the main difference between USTA slide and BRENSO's and FALISTRI's linear slew limiters. Once we have set BRENSO's and FALISTRI's slew limiter, they will apply the same volt per millisecond integration to any voltage change, regardless of its gap or length. USTA's slide, on the other hand, will always calculate the linear integration time based on the stage length. And since USTA is a variable stage length sequencer, it means that every stage can have a different integration time. We have recreated the classic portamento effect with FALISTRI and BRENSO's slew limiter. We can obtain something similar with the USTA sequencer, but this time we can have an independent portamento for each stage. USTA slide can lead to similar result, but allows for more advanced and creative techniques. For instance, one can combine it with some ratcheting gates on the same stage and obtain a sort of microtonal scale going up or down. To do so, set the gate color to green. In this way, USTA will play as many equally spaced gates within the stage duration. We said microtonal because the gates will open mid-air while the CV is sliding between two different values, and they will pick slices of the continuous integration. Another use of USTA slide is to create a sort of complex envelope. In this patch we use the second track of the USTA sequencer to program a series of raw voltages which is faster than the main melody. We can set all of them to the green color and create a complex CV roller coaster in sync with the notes. This was our conversation on Glissando and Portamento. As always, if you have any question, let us know in the comment section below. If you found this video useful or if you want to know more about Frap Tools' approach to modular synthesis, please consider subscribing to our channel and staying in touch with us through our social media.